Good afternoon, class, and welcome to today's lesson. I want you to please be seated, bow your head as we pray. YESHUA HAMASCHIAC, we thank you so much, Appa, for your school. YESHUA HAMASCHIAC school, like Lagos said, teaching us about you, teaching us to you, introducing us to you, that is in helping us to know you afresh. And we ask that you help us in this school, help this teachers and the students, and help me in this class to teach via YHWH, Adonai, feminine side. And we ask that you help other believers around the world to get to know you as the YESHUA HAMASCHIAC movement starts. In YHWH Adonai, YESHUA HAMASCHIAC, amen. And may your students be enabled by you to understand what you're teaching in YHWH Adonai, YESHUA HAMASCHIAC, amen and amen. And so today, in our computer lesson, we're still on computer software part 2. And in this computers part 2, we'll be taking on design and implementation. In our former lessons, you saw us as we went through different types of software. Application was one of it, etc., etc. Now, as we go through software implementation, that is design and implementation, pardon me please. We said that software development life cycle is a framework that project managers use to describe the stages and tasks associated with designing software. So the software development life cycle is a framework that project managers use to describe the stages and tasks associated with designing software. The first steps in the design life cycle are planning the effort, and then analyzing the needs of the individuals who will use the software, and creating detailed requirements. I said the first steps in the design life cycle are planning the effort and then analyzing the needs of the individuals who will use the software and creating detailed requirements. After the initial requirement analysis, the design phase aims to specify how to fulfill those user requirements. After which we get on to the next step, which is implementation. This is where development work is completed and then software testing happens. The maintenance phase involves any task required to keep the system running. So the maintenance phase involves any task required to keep the system running. So what does software design includes? Software design includes a description of the structure of the software that will be implemented, data models, interfaces between system components, and potentially the algorithms the software engineer will use. I said the software design includes a description of the structure of the software that will be implemented, data models, interfaces between system component and potentially their algorithms the software engineers will use. The software design process transform user requirement into a form that computer programmers can use to do the software coding and implementation. I'll take that again. The software design process transforms user requirement into a form that computer programmers can use to do the software coding and implementation. The software engineers develop the software, design iteratively. They develop the software design iteratively, adding detail and correcting the design as they develop it. Sorry about the errors, but I hope you understand me that the software engineers develop the software design iteratively, adding details and correcting the design as they develop it. So in the world of IT and computer programming / software, the adjective iterative refers to a process where the design of a product or application is improved by repeated review and testing. In programming software specifically, iterative refers to a sequence of instructions or code being repeated until a specific end result is achieved. I'll take that again. In programming and software specifically, iteratively refers to a sequence of instructions or code being repeated until a specific end result is achieved. So I hope you understand what we've been saying. So as we said earlier on, the software design process transforms user requirement into a form that computer programmers can use to do the software coding and implementation. And implementation, not implication, please. The software engineers, please note this is live class, develop the software design iteratively, adding detail and correcting the design as they develop it. They'll go on and on and on until they get to their end result. The different types of software design include the following: architectural design. Architectural design is the foundational design which identifies the overall structure of the system. Architectural design is a foundational design which identifies the overall structure. It identifies the overall structure of the system, its main components, and their relationships with one another using architectural design tools. And then, still on the different types of software design, we have high-level design. This is the second layer of a design that focuses. It is the second layer of design that focuses on how the system, along with all its components, can be implemented. This is the second layer of design that focuses on how the system, along with all its components, can be implemented in the form of modules supported by a software track. So what do we mean by in form of modules? By modules, we mean a software component or part of a program that contains one or more routines. Note that one or more independently developed modules make up a program. So an enterprise level software application may contain several different modules, and each module serves unique and separate business operations. Should I take that again? I said by module, we mean a software component or part of a program that contains one or more routines. One or more independently developed modules make up a program. An enterprise level software application may contain, as we said earlier on, several different modules, and each module serves unique and separate business operations. I hope we are together in this. Detailed design is a next type of software design we are going to talk about here, and we have written on today's lesson notes. Detailed design is a third layer of design that focuses on all the implementation details necessary for the specified architecture. The detailed design is a third layer of design which focuses on all the implementation details necessary for the specified architecture. So, what are the six main types? That is, what are the six main steps, involved in developing software? We'll talk more about that later, but let's see how to maintain software quality. Software quality measures if the software meets both its functional and non-functional requirements. That's the standard. Functional requirements identify what the software should do. They include technical details, data manipulation and processing, calculations, or any other specific function that specifies what an application aims to accomplish. So I'll take that again. Here we talk about how to maintain software quality. And we say that software quality measures if the software meets both its functional and non-functional requirements. So, in functional requirements, we say that functional requirements identify what the software should do. What is the aim of the software? Now, to know this, you must know that the aim include technical details, data manipulation and processing, calculations, or any other specific function that specifies what an application aims to accomplish. So non-functional requirements, on the other hand, also known as quality attributes, determine how the system should work. Non-functional requirements include portability, disaster recovery, security, privacy, and usability. Software testing detects and solves technical issues in the software source code and assesses the overall usability. As a software testing detects and solves technical issues in the software source code and assesses the overall usability, performance, security, and compatibility of the product to ensure it meets requirements. The dimensions of software quality include the following characteristics. The dimensions of software quality. What are the dimensions of software quality? They include 1. Accessibility, the degree to which a diverse group of people, that's we, always welcome YHWH, that's the feminine side of the Most High, and here we don't need any other external help. I hope you don't think you go lazy and think YHWH will help you cheat during exams. So, as we are saying, the dimensions of software quality include 1. Accessibility, the degree to which, accessibility here we talk about the degree to which a diverse group of people, including individuals, will require adaptive technologies such as a voice recognition and screen magnifiers, can comfortably use the software. That's 1. Another dimensions of software quality includes compatibility. Here we are looking at the suitability of the software for use in a variety of environments, such as with different OCs, devices, and browsers. And OCs here is capitalized O-S-E-S. Is actually OC, meaning capitalized, is an initial. OSE, meaning operating system environment. So when I say OCs, I'm talking about operating system environments. I'm adding S. Don't forget, OS is operating system. Okay? Those questions will be asked, so please take note. So we said by compatibility, we are talking about the suitability of the software for use in a variety of environments, such as with different OCs, different operating system environments, devices, and browsers. So the next dimension of software quality, in demand or on demand, is compatibility. The suitability of the software, that is what it means. What is compatibility here? It means the suitability of the software for use. No, sorry, we've talked about compatibility. We are going to talk about efficiency now. It's a live class, please pardon me. That is YHWH Virtual School. So the next dimension of software quality demanded is efficiency, which is the ability of the software to perform well without wasting energy, resources, effort, time, or money. Oh, mommy, please give me your data. I need to download the software. And then they give data. Oh my, the software is taking more than 5 hours. Data is going. So here, efficiency is not achieved. So for efficiency to be achieved in the dimensions of software quality, it has. So we give glory to YESHUA HAMASCHIAC for teaching us here, giving the teacher, both the teacher and the student, ability to understand. For tech is wide, and teacher may not know. The brain is put up by YHWH via his son. So don't rely on your teacher's brain. And please pardon us teachers when we misbehave. That's why I call him in the class, because brain can go or you get carried away by a certain problem. So, like I said earlier, one of the dimensions of the software quality on demand is efficiency, meaning the ability of the software to perform well without wasting energy, resources, effort, time, or money. Another one is functionality. Software's ability to carry out its specific function. Yes, dear. What's the purpose of the software? What is it to do? What is its aim? So the dimensions of software quality here includes functionality, which is the software's ability to carry out its specific functions. I hope I'm not going too fast. Please call me back. And if you have any question, Auntie is here. My name is Ada. Don't you know my name again? Adaokwu. So the next one, still on dimension of software quality, is installability, the ability of the software to be installed in a specified environment. Do you understand that? And by the way, when we're talking about environment in IT, what do we really mean? Environment. We know the meaning of environment. This is school environment. I play, I go to play group, I go to SS1, I go to SS2. So in IT, what does it mean? Is it the same thing? No. The term IT environment refers to the infrastructure, hardware, software, and systems that a business relies on every day in the course of using information IT. So some of the commonly used resources in an IT environment includes computers, internet access, peripheral devices, etc., etc. So maybe you will talk to me about IT environment. Would you understand, and what are the different IT environments in your class work after this? So I repeat here again that by environment, because we've been talking about OCs, operating system environments, and we've been talking about environment. So what does it really mean? Is it my compound, my neighbor's compound close to me, my office, a school compound? IT environment says no to this, that IT environment is different from the physical environment of a person. So it means the infrastructure, hardware, software, and systems that a business relies on every day in the courses of using information technology. Some of the commonly used resources in an IT environment include computers, internet access, peripheral devices, etc., etc. So IT environment are actually hardware, software, and systems that a business relies on. Okay, you talk to me about yours. So still on the dimension of the quality of software you produce. As an IT student, you should be able to do this. Manufacture a software, produce a software. Both are one and the same. So the next is localization. This is talking about the various languages, time zones, and other such features a software can function in. So when producing a software, please take cognition of this important software quality dimensions, that localization. So it must be localized to the various languages, time zones, and other such features a software can function in. So we have again here maintainability. How easily the software can be modified to add and improve features, fix bugs. So do not forget, we talked about bugs in the first part of this, and we said, in case you've forgotten the meaning of bugs, that it is an unexpected problem. Please try to see the last visual class lesson, but still I can still tell you bug is an unexpected problem with software or hardware. So typical problems are often the result of external interferences with programs' performances that was not anticipated by the developer. So that's what we mean by bug. Just problem pop up and must be fixed by the software. Next dimension of software quality is performance. How fast the software performs under a specific load. That's one. Another one. A is another important dimension, necessity here for software quality is portability, the ability of the software to be easily transferred from one location to another. Another one is another important necessity or dimension is the software. Necessity is what I can bring to your level. This is SS1, not university. So reliability, but you still need to know tech language here. Reliability is an important dimension in software quality. It's the software's ability to perform a required function under specific conditions for a defined period of time without any errors. Reliability, can I rely on you? It's the software's ability to perform a required function under specific conditions for a defined period of time without any errors. And then we have again scalability. Scalability measures the software's ability to increase or decrease performance in response to changes in its processing demands. Okay. Another one is security. So what's security in software's quality dimension? Security is about the software's ability to protect against unauthorized access, invasion of privacy, theft, data loss, malicious software, etc. So please, WordPress should take note, because some lingual sites written of theirs are being invaded, hacked into. Please, security there is a bit loose. Do something about it. If we are to use WordPress, how are we sure our stores are safe? So if it's written, does that make it impossible for a WordPress site to be secured? Please kindly look into it, WordPress managers. So we're talking about the next dimension here for good quality software is testability. How easy it is to test the software? How easy is it to test your software that you have developed? So here we are not talking about production. I'm sorry, but they're all the same. Developed, manufactured. Oh my! So I've been using software, manufacture, product, but it's actually developed. That's the tech word for it. Another one is usability. How easy is it to use the software you've developed? So to maintain software quality, once it is deployed, developers must constantly adapt it to meet new customers' requirements and handle problems customers identify. This includes improving functionality, fixing bugs, and adjusting software code to prevent issues. How long a product lasts on the market depends on developers' ability to keep up with these maintenance requirements. So when it comes to performing maintenance, there are 4 types of changes developers can make. So when it comes to performing maintenance, there are 4 types of changes developers can make. They include corrective, 1 corrective, 2 adaptive, 3 perfective, 4 preventive. So 1 corrective, here we refer to users often identity. That is, users in corrective performing maintenance. In corrective, when it comes to performing maintenance, we're talking about users often. How users often identify and report bugs. Yes. Users often identify and report bugs that developers must fix, including coding errors and other problems that keep the software from meeting its requirement. Like I just said about WordPress a few minutes ago, I'm a user of WordPress, so that's how I could say that, and I'm saying it openly. Please do something. I'll also report in their site. I've been trying to report, no time. So Harak Agadesh is here. So we welcome Harak Agadesh. Our school is very spiritual. Harak Agadesh is here. It doesn't have to be spiritual. It's we connect with him, the Most High, by faith. So I don't know, spiritual? What's spiritual? Connecting with him who cannot be seen. So he's there, you welcome him. So we say, welcome Harak Agadesh in YESHUA HAMASCHIAC. That's how you teach a child ability to know the presence of the Most High. It's not only when you go to Shabbat service, go to the Vahakala, that is the church, during the Shabbat service, and then they say, he's here. His presence is here. We are saying in his school, his presence is also here. So, when it comes to performing maintenance, we said there are 4 types of changes developers can make, including, may Harak Agadesh teach us as we go on. He's in the classroom. You know that he loves us to learn and learn well. Like he said to Abraham, the patriarch, the Hebrew patriarch, of which we are his children. He said that Abraham may teach his children. He said he will always teach his children. But he said that he may teach his children about him. So that's what I'm doing now. I'm not Abraham, but I can still do the same thing. That's why we have schools. And in school, religious knowledge is important. We don't want CRK, we want the real one. The true YHWH Hamashik. That's the true religion. Thank you, Harak Agadesh. So we said here we said when it comes to performing maintenance, as Harak Agadesh leads us, please Harak Agadesh, can we go on? Yes, he said so. Sorry, I'm your teacher and I hear. Adaokwu is me. Are you jealous? You want to hear? He will speak to you. So one of the next type of changes developers can make includes adaptive. In adaptive, developers must regularly make changes to their software to ensure it is compatible with changing hardware and software environments, such as when a new version of the OS come out. Did you get that? So in adaptive, it means in adaptive, developers must regularly make changes to their software to ensure it is compatible with changing hardware and software environments, such as when a new version of the OS comes out, that is operating system. So going back to WordPress, I have a WordPress site, and before you know it, it said, so I want to download a certain software, and then you see them say, and I really need this software. They'll tell me it's not compatible for your, oh my, how do they say it? For your, I've forgotten that tech language. That is not compatible for the grade, I'm using maybe 5 point something, according to them, it is for 5.8 or thereabout. I said, oh God, help me, I need this. Sometimes I take risk, and when I take risk, I download. Sometimes they don't work, sometimes they work. Even the one I don't take risk, that's actually compatible, do you know it can shut down your site? It shuts it down completely. So that's what Doreen is talking about, adaptive, and I have to start warning, oh my site is locked down. So the next one is perfective. We said it's 4. Okay? In performing maintenance of a software, there are 4 types of changes developers make. So they must make, and one is perfective. These are changes that improve system functionality, such as improving the user interface or adjusting software code to enhance performance. I'll take that again. In perfective, we talk about changes that improve system functionality, such as improving the user interface or adjusting software code to enhance performance. And the last but not the least is preventive. This includes changes that are done to keep software from failing, and include tasks such as restructuring or optimizing code. So I like you to know that software do misbehave, especially in a website application. As a web owner, you should be, developers should be able to add software, install and uninstall easily. Like I told you, software do misbehave, but we look forward to having software that will no longer misbehave, like shut down sites, force a site to shut down. So now, in talking about these, I would like to say that these days we have, like WordPress, for instance, is really improving. There was a time it used to just go off. Backup. These days we have automatic back. There are so many things, my dear. I'll go on and on and on, and we'll talk about some of them later. Modern software development. Modern software development develops in an organizational approach that brings together software development and IT operations team. It promotes communication and collaboration between these two groups. And the two groups are software development and IT operation system. IT operation teams, please. If you're watching, if you are learning from here, please know that it's a virtual school, your YESHUA HAMASCHIAC school. The term modern software also describes the use of iterative software development practices that use automation and programmable infrastructure. So we can get the full picture as we go on. One of these is a treat ultimate guide to develops if it's on the syllabus. Software licensing are relatively inexpensive. These are the few data we've been able to gather. In 1991, the Linux kernel, the basis for the open source Linux OS, is released. In 1997, DVDs are introduced and able to hold more data than CDs, making it possible to put bundles of programs such as the Microsoft Office suite into one disk. In 1999, Salesforce.com uses cloud computing. As in 1999, Salesforce.com used cloud computing to pioneer software delivery over the internet. In 2000, that is the year 2000, the term software as a service, SaaS, comes into vogue. In 2007, iPhone is launched. iPhone was launched, not iPhone is launched. Was launched, and mobile applications begin to take hold. In 2000, again to the present, DVDs are becoming obsolete. That's from 2010, sorry, not 2000. From 2010 to the present, DVDs are becoming obsolete as users buy and download DVDs began to become obsolete as users buy and download software from the internet and the cloud. Vendors move to subscription-based models, and SaaS has become common. So that's the end of our lesson for today. The next lesson come up still on software. We'll take up application software as a topic. Until I meet with you again, please talk. You're going to write as your assignments about the OSE. Okay. In this case, OSES, operating system environments. Please submit immediately after the class.